Okay, let's just jump right in because it honestly feels a bit like the world's been turned upside down. For the last 10 years, the script has been so simple, hasn't it? It's been binary.
Completely binary.
If you care about the planet, you buy an electric car. If you don't, you stick with gas. Electric is clean, gasoline is dirty. End of story.
That has absolutely been the dominant narrative. It's a very clean story, fits perfectly on a bumper sticker.
Exactly. But here we are, it's January 2026, and that script is flipping. We're looking at a stack of sources today that center around a figure who's effectively standing up and telling the entire auto industry, hold on, you've got the math wrong.
We're talking about Akio Toyoda, the chairman of Toyota.
Right. And he is making some serious waves, suggesting that in certain places, specifically places like Canada, where it gets really cold, driving a full EV might actually be, quote, dirtier than a hybrid.
It sounds totally counterintuitive, doesn't it? Almost heretical, given the massive push for electrification. But what's fascinating here is that this isn't just a CEO protecting a legacy business. He's bringing data to the table.
He's talking about resource efficiency, he's talking physics, and he's talking about the cold, hard reality of our power grids.
And that's our mission for this deep dive.
We're going to unpack why the greenest choice isn't always the one with the plug. We need to talk about something called the 1.6.90 rule, which blew my mind, by the way, and the reality of Canadian winters.
It does. It changes the math entirely. And I think the key here, before we get into the numbers, is to frame this correctly. The sources aren't anti-EV.
No, not at all.
It's a lesson in what's called life cycle thinking. It forces us to look beyond just the tailpipe and consider the entire system, from the mine to the power plant to the thermometer on your dashboard.
The whole picture. So let's start with that headline. This 1.6.90 rule, it sounds like a secret code. What is it?
It's Toyota's internal formula for resource allocation. And it's really the key to their whole strategy. We start with the premise that battery minerals, lithium, cobalt, all that stuff are finite.
Right. We can't just wish more into existence.
Exactly. So let's break down the numbers. The 1 represents the amount of raw materials you need to build one single long-range battery for a fully electric vehicle, a BEV.
Okay, so 1 is that huge battery pack under the floor of like a Tesla or Ford Lightning, a massive slab of minerals.
Correct. Often weighing over 1,000 pounds. Now, the 6 is the number of plug-in hybrids PHEVs you can build with that exact same pile of raw materials.
Okay, so 6 cars with a smaller battery and a gas engine for the same mineral costs, the kind you plug in for maybe 60 kilometers of range, but then they switch to gas.
You got it. But here's where it gets really interesting. The 90, with that same amount of lithium, you can build 90 traditional hybrids.
90.
Think of a standard Prius or a Corolla hybrid. The ones that don't plug in but have a small battery to help the engine.
Hold on, I want to make sure I've got this. One giant EV battery has the same amount of critical minerals as 90 small hybrid batteries.
That is the ratio, 1 to 6 to 90. And this leads right to the core of Toyota's argument. It's about spreading the green.
Okay, but I see the resource argument, but how does the math work for the actual environment? Because my gut says one zero-emission car is better than 90 cars that still burn gas. How can that be better?
That is the binary thinking we have to move past. Let's run Toyota's scenario. You have a limited pile of lithium, which we do. You use it to build one big EV.
Okay, one zero-emission car on the road.
One person is now perfectly green. But what are the other 89 people in this theoretical group driving?
Well, I guess they're still in their old gas cars since there aren't enough batteries for them.
Precisely. You have one clean car and 89 high-emission cars still on the road. The average emissions of that group barely moved.
Ah, I see where this is going. It's an issue of scale.
Right. Now take that same pile of lithium and build 90 hybrids. You are now displacing 90 conventional gas cars. You're upgrading 90 drivers from a vehicle that gets maybe 10 liters per 100 kilometers to one that gets 4 or 5.
So you're lowering the collective emissions of the whole group in a big way, instead of perfecting the emissions of just one driver.
Correct. And Toyota's own calculation claims that the 90 hybrid scenario is 37 times more effective at reducing overall carbon emissions than the single EV scenario.
37 times.
37 times.
Wow! That is not a rounding error. That's a massive difference.
It's huge. And it comes from the law of diminishing returns. That giant battery in a long-range EV is dragging around a ton of weight and potential that statistically most people almost never use.
Right. Most people drive, what, 40 or 50 kilometers a day, but they're hauling a battery designed for 500.
It's like carrying a giant hiking backpack full of food just to walk to the mailbox.
That's a perfect analogy.
You're spending energy to carry energy you don't need. Toyota's asking, why lock up all those scarce resources in one car for just-in-case road trips when you could spread them out and help 90 people cut their fuel use every single day?
It's a utilitarian argument, like budgeting.
Yeah.
You could buy one person a mansion, or you could build 90 modest, energy-efficient apartments.
Exactly. It's all about resource allocation, especially when mining lithium is not exactly a gentle process for the Earth to begin with.
Okay, so that's the resource argument. But the sources get even more specific to Canada. They start talking about this dirty grid problem. And this is where I feel like a lot of people just assume electricity is magic.
It's absolutely vital to this whole discussion.
Yeah.
The source makes a really provocative claim. Not all electrons are created equal. We think electricity is just clean, but the plug in your wall is just a delivery system. The wire is a pipe. The real question is, what's making the power at the other end of that pipe?
Right. And in Canada, that changes wildly depending on which province you're in.
It really does. The source breaks it down into clean zones and dirty zones. If you're in Quebec or BC or Manitoba, you're in a clean zone. Your grid is mostly hydro.
So massive dams, running water, basically zero carbon generation.
Exactly. So if you drive an EV in Montreal or Vancouver, it is undeniably the cleanest option. The electricity is green, so the car is green. The equation works perfectly. But the story changes a lot when you move into the prairies, Alberta and Saskatchewan.
The so-called dirty zones.
Relative to BC and Quebec, yes. Their grid still relies heavily on natural gas and, historically, coal. It's a carbon-intensive grid. You're burning fossil fuels to make the electricity. And this introduces a concept called carbon debt.
Okay, carbon debt, that sounds ominous.
It is. Think about how the car is made. Manufacturing a 1,000-pound lithium-ion battery is incredibly energy-intensive. You have to mine ore, ship it around the world, refine it. All of that emits CO2.
So before an EV even leaves the lot, it's already responsible for more emissions than a comparable gas car.
Yes. It starts its life in the red. It owes a debt. The only way to pay off that debt is by driving it. And every kilometer you drive on electricity instead of gas, you save a little CO2, paying down that debt.
I get it. So if I'm in Quebec, that debt gets paid down fast because the electricity is so clean, maximum savings.
Precisely. You might pay it off in, say, 20,000 kilometers. But if you're in Alberta, charging that same battery with electricity made from natural gas, well, the payback period stretches way out.
Because the electricity itself has a carbon footprint.
A significant one. The source suggests you might have to drive that EV for years, maybe 50,000, even 100,000 kilometers, before you actually break even with a super efficient hybrid.
That's wild. So I could have a full EV in Calgary on a 3-year lease, drive it the whole time, and hand the keys back without ever actually being cleaner than my neighbor in their Prius.
That is the cold truth Akio Toyota is talking about. You could be driving around feeling great about saving the planet, but the life cycle math says you haven't even offset the manufacturing of your own battery yet.
And this is 2026. Grids are getting cleaner, but not overnight. So for right now, geography dictates reality.
It does. And speaking of geography, we can't talk about Canada without talking about the weather.
Right. The physics of winter, as the source calls it. And looking outside, it is definitely winter.
It is don't stick your tongue to a flagpole weather, for sure.
And that cold is the enemy of batteries. We know this, but the source really connects it back to the whole green argument.
When it drops below minus 20 Celsius, EVs lose a lot of range. It's not a small dip.
I've heard horror stories, people losing 30, 40, sometimes 50% of their range in a cold snap.
It happens.
Yeah.
And it's simple physics. The chemical reactions in the battery just slow way down. But the bigger issue is keeping yourself warm. In a gas car or a hybrid, heat is basically a free byproduct.
Explain that. Why free?
Well, a gas engine is really inefficient. It wastes a lot of energy from gasoline as heat. In the summer, that's bad, but in the winter, that waste is exactly what you want. You just poke it into the cabin to stay warm. It costs you almost no extra fuel.
So the engine is a giant space heater that also happens to turn the wheels.
Pretty much. But an EV is too efficient. It makes very little waste heat. So to keep you from freezing, it has to drain the main battery to run a heater. That energy isn't moving the car, it's just fighting the cold.
You're burning through your tank just to keep your teeth from chattering.
And this creates what the source calls a double whammy when you combine it with the dirty grid argument.
Oh, I see where this is going.
If your EV is, say, 40% less efficient in the winter, you have to charge it 40% more often to go the same distance.
And if you're charging it more often on a carbon-heavy grid, like in the
Your
prairies,
grams of CO2 per kilometer metric just skyrockets.
wow. So during a cold snap in Alberta, that EV could be significantly more carbon intensive to operate than a hybrid that's just happily using its own waste heat.
That's the connection. It's not just batteries don't like cold. It's cold makes EVs thirstier for dirty electricity.
It's all about using the right tool for the environment. You wouldn't wear a bikini to a blizzard just because it uses less fabric.
That is a vivid image. But yes, the tool has to fit the task.
So let's zoom out. We're in 2026. The market is shifting. The sources mentioned federal rebates have been scaled back. There's a market cooling for EVs. The initial hype wave seems to have crashed a bit.
We're seeing a correction. The early adopters, the tech fans, they've all got their EVs. Now we're trying to reach the mass market, and they're a tougher crowd. They care about cost, reliability, convenience.
They don't want to plan their road trip around a map of potentially broken chargers.
Exactly.
Yeah.
Which is why hybrid sales have surged. They're the bridge. You get lower fuel costs without the range anxiety.
And Toyota seems to be playing the long game here. People called them dinosaurs for being slow on EVs, but this suggests they're not anti-EV, they're just waiting. What for?
For the tech to mature, the source explicitly mentions solid-state batteries. Toyota's hoping to pilot those around 2027 or 2028.
And how is that different from what we have now?
Current batteries use a liquid electrolyte. They're heavy, they're flammable, they hate the cold. Solid state replaces that liquid with a solid. They promise to be lighter, charge way faster, handle the cold better, and use fewer of those critical minerals.
So Toyota's argument is basically, why flood the world with these heavy, inefficient liquid batteries today when we can sell millions of hybrids to cut emissions right now and then switch to the real solution in a few years?
That's the gamble. Akio Toyota is betting that by 2030, today's EVs with their liquid batteries will be degrading, their range will drop. Meanwhile, the hybrids sold today will still be running just fine.
He's arguing that rushing a technology that isn't quite ready might actually slow down our progress.
It's the torture of good enough versus perfect. Do we embrace the good enough hybrid now or hold out for that perfect EV future?
And that puts them in tension with government goals. The Canadian government wants 100% zero-emission vehicle sales by 2035. That's coming up fast.
Very fast. And the Toyota philosophy suggests that forcing that transition before the grid is ready everywhere and before the tech is ready could create a backlash.
Yeah, if someone buys an EV, hates it because it freezes in the winter and goes back to gas, you've lost them for good.
Exactly. The argument is for a diverse approach. Let Quebec and BC go full EV. It makes total sense. Let the prairies transition with hybrids while their grid cleans up. The right tool for the job.
So what's the big takeaway for someone listening right now, maybe thinking about their next car? It sounds like there's no single right answer.
No, there isn't. The takeaway is context. The best environmental choice depends on your postal code. It depends on your thermometer. And it depends on that 1.6.90 rule. How are we allocating these scarce resources in the best way?
It really challenges the moral superiority that can sometimes come with EV ownership. Just because it has a green license plate doesn't automatically mean it's the greenest thing on the road in every context.
Which leads to a final question I think is worth considering. It's this concept of environmental theater.
Ooh, tell me more. That sounds provocative.
Well, think about it. If we rush to adopt a technology like full EVs in places where the grid doesn't really support it yet, are we actually making an impact? Or are we just performing environmentalism?
Are we buying the costume of a superhero without actually having the powers?
Precisely. Are we buying the symbol of a green future without doing the math on the present reality? The 1.6.90 rule suggests that sometimes the unsexy solution, that hybrid Corolla, is actually the heavy lifter.
Just because it scales better.
Because it lets 90 people participate in reducing emissions instead of just one. It democratizes the green transition instead of making it a luxury product.
That is a heavy question. Are we performing or are we solving? Turns out the boring answer might be the most revolutionary one.
Often is.
Well, on that note, I think I'm going to look at my own car a little differently, and I'd encourage you, the listener, to do a little research on your local power grid. Find out where those electrons are actually coming from before your next big purchase.
Don't just check the price tag, check the power plant.
Absolutely. Knowledge is power, quite literally in this case. Thanks for diving in with us.
My pleasure.
We'll catch you on the next one.